Hi, my name is Liam Foley, and welcome to my poster entitled The Role of Timbre, Envelope, and Movement on Audiovisual Integration of Musicians' Movements. Right now, you are hearing my voice and seeing my lips move. Despite information coming from two different sensory modalities, you're able to perceive both events as a single percept. This ability is called crossmodal binding, and is incredibly important for our understanding of our environments. When at the theaters, it's also what allows us to hear the sound is coming from the screen, despite the speakers being in various locations around the room. Numerous properties of acoustic and visual stimuli can affect how well two stimuli bind together. Here, we sought to investigate the role of natural auditory stimuli play in our binding of sight and sound. Previous investigations have found differences that amplitude envelope plays an important role in binding. With percussive sounds, characterized by a steep onset to maximum amplitude followed by an exponential decay, facilitating better binding than flat sounds, which are at maximum amplitude for the duration of the tone and are usually the de facto auditory stimuli in auditory perception work. However, natural sounds in our everyday environment are predominantly percussive, while flat sounds are synthetic and don't have many, if any, natural reference. These are sounds like the beep of your microwave. So we sought to explore whether natural sounds with percussive-like envelopes would bind better than a flat envelope sound. To study this, we use a temporal ordered judgment task, where participants are presented with two stimuli of various asynchronies and indicate which came first. For our visual stimuli, we had a dynamic stimulus, a point light rendering of a marimba player striking a mallet, and a light flash, which are commonly used in TOJ tasks. For our auditory stimuli, we had a flat, pure tone, which are predominantly used in TOJ tasks and many other areas of auditory perception. And for our percussive sound, we had a real recording of a note being played on the marimba. We then combined each of the audio-visual conditions, and from these trials, we're able to determine the just noticeable difference. The JND is the time interval in which two stimuli must occur for a person to perceive them as occurring at different times. So a higher JND value indicates better binding because it requires more of a time separation for two stimuli to be viewed as separate events. In line with our hypothesis, we see a greater JND for the percussive audio condition compared to the flat pure tone, indicating better binding across both visual conditions. In conclusion, we find support for our hypothesis that natural sounds will bind better than abstract tones. Future investigations, however, should further investigate timbre and temporal variation in the binding of auditory stimuli, while further investigating what factors of visual stimuli, such as realistic movement, affect binding. And beyond bettering our understanding of crossmodal binding, this understanding of the role that vision and audition play in our integration will help develop more intuitive products, such as video calling services, where binding of sight and sound are paramount to our conversation. I would like to thank everyone who has worked on this project. Without your hard work, all this would be impossible, and I invite you to follow me or the lab on Twitter to find out more about the work we do. Thank you for your time, and stay safe.